How do you tell people to think about that when they're looking at the reports?
Yeah, so there's a couple things I think we see common. The big one, or sort of one of the early on ones, is when we started doing our pricing, when we started our website, really, we did it holistically at a county level. So we didn't really have a drilled down pricing model. We just sort of did a county-wide analysis. Say you wanted to price a 5 acre parcel. We would say, okay, from let's say 3 to 8-ish acres, let's get all the comps and let's just do sort of a generalized model for that, which was fine sort of for the intent that we were going for when we first launched, which is sort of just ballpark an idea. But obviously some counties are pretty large and have a wide array of costs. So we then moved to city pricing, and then from city pricing moved into sort of what it was now called our geo pricing, which is sort of what you would conceptually think as you have a single property, you find all the comps in the immediate vicinity, and then you're able to price that. And so that's the one we typically recommend. That's the default one in our platform now, although we still have the county and city pricing as an offering because those have custom available where you could come in and you could say, hey, I'm already going to set a price per acre. I just want sort of like those to be applied across my data list. But with the geo pricing model that you're looking for, things that might trip you up, I think one of the big ones we've seen is when you get properties that are really close between rural and vacant areas where you have, say, I always use the example of right on the outskirts of Maricopa County, within maybe say a 5 or 10 mile radius, you might have, fully built structure houses, industrialized area, commercial zone, everything. And then just a few miles to the east, you have just the desert wasteland. And so when you're pricing that, when you're looking at it just from like a data or a numbers perspective, it's hard to really see that divide. And so sometimes you'll see the comps that you're getting with your property. You have some for 200,000 an acre and some for 5,000 an acre in a very short area. And so there's a challenge for us to kind of come up with that number for you, just because it's hard to know where your property falls into that spectrum. And so one of the metrics that we use pretty frequently is this idea of this coefficient of variation. So we're basically looking at a statistical measure of how far apart are the comps in this model. If I pull in 50 comps to do to analyze your property and they are hugely dispersed, so like in that example, 200,000 an acre and 10,000 an acre, I'm going to have a little less confidence in creating that model because I just don't know, or me being priced doesn't know where in the spectrum it lies. Conversely, if we have every comp within a 10-mile radius is at 20,000 an acre, we have a pretty high degree of confidence, where your property is going to sit. So we're able to sort of do an analysis that way as part of our internal modeling.
Interesting. Is that called the Gini coefficient or something like that? Is that similar?
Don't think so. The coefficient of variation just sort of is like a raw so it kind of factors out acreage. So we look at it just as at a price per acre level, and it's just sort of normalized from 0 to 1 essentially.
What do you think is going to happen? Like, what's next with AI as far as trying to solve problems like that? Do you see it being able to come in and start making those decisions? How long do you think that'll remain a problem to solve?
Yeah, it's a good question. I think one of the benefits, and we started to look into this in our platform and our business, is sort of like not maybe AI from that problem, but from like if we took a step back and looked at basic image recognition software for AI. One of the challenges we found is that a lot of times with vacant land, it's not always vacant, right? And so you end up with this problem where you have data that is saying, hey, it's worth this amount of money. It's a vacant lot. And you say, great. So I'm going to use that, whether it's as a comp or as the property I'm trying to price. And you kind of go with what that information is. But then it turns out there's, a barn or a house built on it. And obviously it completely changes the value of the property. I think with things like image recognition, where you have Google Earth, who is constantly imaging everywhere across the US or really the world, but for what we're doing for the US, you can maybe make some more decisions and have some more information that is not readily available to you through, say, like a listing site, because you're able to now add another layer of information to your pricing model, whether that be structures on the property, whether that be, hey, what kind of land, what kind of land is this? Is it farmland? Is it just dirt? Is it XYZ? We've looked at it for things like road access too. Can you physically see a road moving through the property or around the property? So I think that kind of unlocks another layer of analysis when you're looking at, pricing these properties and just analyzing these properties in general, when they're especially in some of these remote locations that a lot of folks that are in this space are not physically going out to every property that they're looking to purchase.
Yeah, there's so much there. Image recognition is probably some really that's going to be some big developments, and it'll be exciting to see, because you could also, I guess, hypothetically be looking at stuff like the layout of the property or the trees that are on it. And are you already looking at the topography pretty thoroughly? And is that part of your pricing?
We do. We look at the topography and we analyze basically the slope profile. So what we're mostly looking for, and this is one of the features we have in our both in our comport, and we have a filter tool on our export where we can say, hey, if you go into the export workflow, you can only return the properties that have at least 50% flat slope. So if I'm looking for a property that can build a home on, if I'm looking for between 3 and 5 acres, I want properties that have at least, X amount of acres that are considered flat where I can build a structure on. And so what we're able to do is look at all the contours of the property and then filter out all of those extreme slopes where it's just constantly, going in and out.
And with that, it's also, you want to be cognizant with AI is so awesome, but it can also make mistakes in certain degrees, or maybe just the underlying data from a certain data set can actually be more accurate than using it. Certain examples of that is, so for image recognition, right? When you have road access information, if you have that underlying information available and it's already checked out, that may be accurate, more accurate than image recognition, because there could be clouds, there could be trees, there could be something in the way that actually doesn't show you that there's a road right there, where the underlying data may just already have that information that you don't need to be able to see through anything, and the data is just there. Similar with topography, right? So you always have to be, it's cool, but you have to be careful with when to use it. Or if you do use it, understand that there could be like drawbacks because of that, and maybe workarounds to kind of overcome those situations. But that's what's kind of a mix between the underlying data that can help, plus adding AI on top of that is really kind of the layering that is starting to get pretty cool.
Yeah, it's really interesting. Talking about data, and you probably see so much information come through and so many data pulls and things like that.